Welcome, class. And this time we get to deal with the fun and exciting topic of Sig Figs and Sig Fig Math. The purpose of this short video is to review precision and accuracy and why we need to count sig figs, how to count sig figs, applying the rules for sig figs, and then briefly discussing metric conversions and dimensional analysis. So why is it we have to deal with sig figs, significant figures? Well, that's because there's uncertainties in measurement. In fact, equipment has limitations. Maybe your scale only goes to the tenths place. Maybe it goes to the thousandths place. Rulers are only so accurate, and you can only be as accurate as your weakest measurement tool. Also, we humans have errors. If you ever had to read a graduated cylinder and it was in between two numbers, I might say it was 19.5. You might say it was 19.3. Those are human errors. Let's discuss quickly precision versus accuracy. Precision is how closely individual measurements agree with one another, while accuracy is how closely those individual measurements agree with a correct or true value. To help you out, here's a quick little diagram that I got from the internet. If you notice the first picture, it's both low accuracy and low precision. You weren't near the bullseye, and they were not all grouped together. Now in the second picture, it's high precision because all of your darts are in one location, but you're not accurate because you didn't hit the bullseye. And the third one, you're accurate because you hit the bullseye, but you're not precise because they weren't all grouped together. While the last picture shows both high accuracy and high precision. In uncertainty and sig figs, you need to know that the greater the number of sig figs, the greater the precision of the measurement. And also, when we write down a number, all of those digits, except the last one, are known digits. That last one is estimated. Go back to the graduated cylinder example. If I say 19.5, I know for sure it's 19. It's between 19 and 20. But I don't know that it's exactly 0.5, could be 0.3, could be 0.7. We just don't know. There are rules for counting sig figs. Now these are written in pretty plain English. First, you count all non-zero numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Zeros that are between non-zeros are significant. So 1003, 1003. Those zeros are between non-zeros, a 1 and a 3, and we count them. So 1003 would have 4 sig figs. Zeros at the beginning are never significant. We call those leading zeros. Zeros at the end are significant if they are after the decimal. Zeros that are trapped or after the decimal and at the end do count. Now that you can count sig figs, let's apply them in math. There are different rules for adding, subtracting versus multiplying and dividing. And honestly, 98% of the time in chemistry, we multiply and divide. For adding and subtracting, it's based on place value. So look at the first example, 20.42. There are 2 places after the decimal. 1.322 has 3 places after the decimal, and 83.1 goes to 1 place. So your weakest measurement tool only goes to the tenths place. Therefore, your answer goes to 1 place after the decimal, 104.8. Now look at the next example. This one's a little trickier. 740 rounds to the tens place, 612 goes to the ones place, but 800 goes to the hundreds place. Your least accurate number is the hundreds place. 800's not that exact. It could be 778.96, and that would round 800. So when you add all those up, you get 2,152, but we will round it to the hundreds place. It's 2,200 and not 2,100 because the 5 makes the 1 round up. My favorite rules, multiplying and dividing. I just think they're a lot easier. When you multiply or divide, count the number of sig figs in each value that you're multiplying or dividing. And the rule is that the fewer numbers of sig figs is how many sig figs your answer should have. For example, 6.221, there are 4 sig figs, but 5.2 only has 2. So even though 32.3492 is your answer, we're going to go with 2 sig figs. So we're going to stop at the second digit, 32. Please pay attention to what comes after that. There's a 3. That does not round up the 2, so the answer is 32. Make sure you round correctly. For mixed math problems, follow the order of operations like you've been taught in math and do sig figs along the way. If you put everything in the calculator and then try to apply sig figs, you will not get the right answer. Now, I'm not that harsh of a grader, but my son, when he was in college, the computer program was very particular. If you didn't do sig figs along the way, you did not get the right answer. So in my example, it's both an addition and a division problem. Well, if you guys remember the order of operations, you're going to start with the parentheses first. So 124.6 divided by 4.7. Well, when you get that, you only use 2 sig figs because 4.7 is only 2. So that gives us 27. Now you add the two numbers, 52.34 plus 27. Well, adding goes with place value. 0.34 is 2 decimal places. 27 doesn't have any decimal places. So we're going to round our answer to the ones place, which is 79. By the way, that's thunder if you heard it. Let's start with dimensional analysis. It's really just a fancy way of saying conversions. Now, metric conversions are probably the easiest. Guys, it's just bunny hopping. If you look at the middle of the slide, the KHD, MD, CM, I was taught a silly phrase when I was back in high school. Kittens have dirty mittens during Christmas meals. The L stands for liters, the G stands for grams. Feel free to come up with other sayings. Kittens have dirty lips during Christmas meals. Kittens have dirty gloves during Christmas meals. I don't know why, but I picture a bunch of kittens sitting around with cute little hats and little gloves on, and they're having a tea party. But I know the math teachers usually say King Henry died drinking chocolate milk or something like that, but they always leave out that middle section, the liters, the meters, and the grams. When you're doing metric conversions, a lot of students struggle with how to write it as an actual fraction. Like they can bunny hop, but they don't know how to do the conversion thing. For example, how many millimeters are in a kilometer? Here's what I recommend. You write down the kittens have dirty mittens during Christmas meals. Take whichever letter is bigger. And you guys know that on the left are the bigger values. A kilometer is a lot bigger than a millimeter. And give that bigger value a 1. And then every time you move to the right, add a 0. So there are 10, I believe that's heck meters, I don't know, some word we never use. Then D and then M. So there are 1,000 meters in a kilometer. Keep going. 10,000 decimeters, 100,000 centi, 1,000,000 millimeters. And before we get into the next part where we start looking at the more fun conversions, remember to use labels. They are your friends. We're going to spend quite a bit of time practicing our conversions. I mean, that's chemistry. We do it all the time. Grams to moles to molecules, etc. Sometimes there are tricks. So take a look at this one. 27 feet cubed to centimeters cubed. Write down what you know, dot line. You've heard me say this a million times. So we write down 27 feet cubed, dot line, and that's where we're going to start our conversion. Well, I don't want feet cubed, so I'm going to put feet on the bottom, and you know that 1 foot is 12 inches. But if I only write 1 foot, I don't get rid of the feet cubed. You have to cube that number and the label, same on the top. So it's going to actually be 12 cubed. And that'll give you inches cubed. Then the next conversion, 1 inch is 2.54 centimeters. But again, you have to cube both values or you will not get rid of the label and get centimeters cubed. Now you notice we get this pretty ugly number. And why did I round it to 760,000? Well, go back to the beginning. 27. 2 sig figs. Your answer will have 2 sig figs. Let's do one more fun conversion. This one's a little complicated. It's $6.99 per gallon. And normally we write things on a slant, like per gallon. But when you're doing a conversion, write it a number over another number. Don't write it at a slant or you won't be able to see your labels cross off correctly. So all I need to change here is gallons into liters. So we're going to do 1 gallon is 4 quarts, quarts into liters, and that gives me dollars per liter. So take a look. Gallons cross off, quarts cross off, and what's left? Dollars and liters. And you've got your answer. Now why $1.85? Because again, $6.99 is 3 sig figs, so your answer will have 3 sig figs. And by the way, all of these weird conversions like 1.057 quarts is a liter, I will have those for you on your homework assignment.